Welcome to week 5's lecture video where we cover lesson number 7. It's all about implementing authentication controls. So let's kind of dive in. I believe there's 4 different sections, and it basically continues the whole protection theme of kind of protecting your technology. This lesson also covers the IAM, so that's the Identity and Access Management configuration. It's good to know, especially in the cloud computing sector. IAM is pretty extensive in that environment. So whether it's the Google Cloud Platform or you know Amazon Web Services or Azure through Microsoft, there's many different types of clouds, but they all seem to have this. And I think maybe if it comes up, I'll show you the cloud that I have and how you can have your own cloud. It's all open source, so you can get it all running and stuff. Topic 7a. This is where you are summarizing or summarizes the authentication and design concepts. So, and I think the first thing we'll talk about is again, identity and access management, all right, which is the abbreviation for IAM. I think that it's important to be able to distinguish between identification and authentication, right? So that's another thing. So identification is where you're creating an account or ID that uniquely represents the user, the device, or the process on the network. Authentication is proving that a subject is who or what it claims to be when it attempts to access the resource. So again, we do need to understand the differences here. And again, this whole concept, identity and access management, really reflects the importance of identification, of the entire identification component to technology. There are different types of authentication factors. Multi-factor authentication is something that a lot of you guys should already be familiar with, especially if you've taken the A+ or the CompTIA Network Plus course. So it pops up here as well. CAPTCHAs will come up here sometimes where you have to prove that you're not some computer. There's something called biometrics, pins, swipes, ownership factor, key fobs, tokens. I think the key is I can't stress this enough, is two-factor of authentication. So if it's something you're trying to log on to that you really care about, namely bank accounts and like your cloud accounts, you want to make sure that you have multi-factored setup. Now sometimes it doesn't even appear to be set up because maybe in the past you put that you trust your computer, so every time you're on your main computer, it probably you probably don't have to do the two-factor authentication. But the moment you try to sign on to a machine that you normally don't, you may have to do the two-factor authentication. I think it's a little suspect when they force you to do two-factor and you didn't really set it up. Some school accounts where you log in with your school account, they may sometimes prompt you to do two factors. I guess that just has to do with the, the kind of the authentication design. So let's move on. It's that CIA piece again, as you can see, the confidentiality, the integrity, and the availability. This is kind of what is the aim for when, we have this sorts of things set up. Again, what are the different types of multi-factor authentication? Like I have several on my phone. I have the Google Authenticator, and then I also have the Duo Mobile. And basically, I use it for my Slack channels and, Amazon and, just secure places. And basically it generates a code like every 20 seconds. And so when you log on to that, it proves that you have the device and it proves that you have access to that multi-factor. And then that code you have to have, it's a good timestamp. And without that extra authentication, code, you won't be able to get in. I know a lot of Instagram accounts we have it, and it is one of the best ways to prevent from getting phished. Clicking on a website and logging in, and then somebody else stealing your username and password. But if they don't have that second authentication, then they're not going to be able to get in. So next we're going to look at the authentication attributes. And it kind of, sometimes even having a key card like at Everett, at our college, to get into the buildings when it's locked, I have a card, and I have to put the card up against, in the building, in the Rainier Hall. I'm not sure the Scouts maybe, but I don't have the key to that building. No, I don't have the code to the front door like I do for Rainier. But that code basically proves that I'm somewhere, and it also proves that I actually have access to that card. So just like a credit card is a form of identification, the card itself, even though it may not have your picture. If it has your name and you're claiming to be the person that name belongs to, it does have some credibility. And also, if you think about it, the probability of having the card and not being the person, and being the same person whose name is on that card, I mean, the probability of that not being possible is very low. So I don't know. It's one of those things. So here, the attributes is somewhere you are, something you can do, something you exhibit, someone you know. And that web of trust, that's basically where new users are kind of vouched by kind of existing users. Or as a user participates in the network, their identity becomes better established. So one example of that would be kind of the decentralized web of trust model, where they use the PGP kind of thing as an alternate to the PKI. So, all right. Now we're going to get into authentication design concepts. And there's two main objectives here. You're given a scenario, analyze potential indicators to determine the type of attack, and also given a scenario, implement authentication and authorization solutions. All right. So let's first look at the local network and remote authentication, where there's the Windows authentication. I mean, that's pretty popular. We see that a lot. Kerberos authentication. Here it is. Here's the setup. Keep in mind, Kerberos is a single sign-on network authentication and an authorization protocol used on many networks. It's also used for the Azure, so the Microsoft's web cloud network. It basically sets up some sort of key distribution center where it's passed on so that you're able, once with that one key, it's kind of like a master key that unlocks all of your access. And it's apparently pretty good. They call it ticket granting and things of that sort. So Kerberos authorization is here. It's a multiple step process. Presuming the user entered the correct password, the client can then decrypt the ticket granting service, like a service session. And the service session key, and that kind of establishes the client in the KDC. So now they all know the shared secret. And the client cannot kind of interfere with the TGT, the ticket granting ticket. Okay, let's move on. In your lab, you'll be going over these sorts of things. There's a password attack lab as well. Let's get there. The best defense against password crackers is to kind of ensure to use strong passwords. Oftentimes I'll use, when I'm signed into my browser, you have the ability to suggest a password to be used when you're creating an account. Now you can't suggest it. This is just for the Google Chrome Google users. It won't suggest the password if you're not synced to your browser. But once you're synced to your browser, you can suggest strong passwords, and every time you log back to that same account, the strong password would pop up. The drawback is that sometimes if you're on your phone, you may not have access to it because you have to sync the Google Chrome browser in your mobile, and you might not have that app to do that. And it's happened to me a few times. So what I would try to do is just log into my browser, look at the password and copy it, and then just, even if it's a complicated one, and then bring it over. I feel pretty secure that way. Many other strategies. I think the brute force is one. There's tons of different kind in Kali Linux that you can use, and they even have For the dictionary ones, they'll have a list of passwords, like commonly used passwords. I mean, there are so many different um, files out there, you know, gigabytes, that it just has millions of different passwords, and they'll try each one. You just sit there and let the machine run. But that's actually, it really only works good if you know that the password that you're trying to crack is a weak password. Here's some more. There's something called the rainbow table, a hybrid attack. Fuzzing of dictionary terms. I mean, it's a big business to be able to have somebody's password. It's one of the easiest ways to gain access to someone's machine, is to simply know their password. All right, let's look at password crackers. The Hashcat, brute force dictionary, Kane, and the low tag. Yeah, there's a lot of different kinds. This is kind of how it works. Topic 7C, implement authentication technologies. So here you'll see the smart card, um, key management devices. These are a nice kind of way to keep things secure. Sometimes you'll see this on doors. If you've ever gone to the courthouse and you've had to go to another room inside there, you'll notice that there's you have to put your key up against the door to gain access. It's pretty locked down pretty well. All right, and here's where you get into the assisted lab, managing centralized authentication. And the last topic in 7 is to summarize the biometrics authentication concepts. And so here part of the exam was to summarize authentication and authorization design concepts. And biometric, that's where, again, sometimes you can um, unlock your phone by um, by your face. All right. It kind of also implies that if I have biometric turned on, does that imply that my camera is always on? Um, waiting to see my face so that it could unlock itself. Um, and the answer is maybe. Um, maybe. You can run a test. If your phone is locked and you just hover your face over it without even picking it up, will it unlock? And the answer is yes, it will. So that does imply that whenever your phone is locked, it is pretty much always on. Now, when it's sleep, I don't think the camera is watching. That would drain the battery quite a bit. All right, let's move on. there's something called vein matching. Okay, I'm even sure that there's something with embedding chips into people. Um, I know there's people who've gotten tattoos of their Bitcoin address or some kind of QR code or something on their arm. Or here we have apparently your retina is unique to you, and it can be learned through the machine, and it could, kind of see, how you can be identified by your retina, the pattern of your blood vessels and things of this sort. Apparently, blood vessels don't change much, so it's pretty sad. So if you have a lot of red veins, those things may not go away. Behavioral technologies. And that pretty much rounds off the slides. But what I'd like to do is look over some of the questions. Um, these questions are like potential test questions. So let's take a look. Number one, what is the difference between authorization and authentication? And we talked about this a little bit earlier. See if I can make this bigger. Authorization means granting the account that has been configured for the user on the computer system the right to make use of a resource, whereas authorization manages the privileges granted on the resource. And authentication protects the validity of the user's account by testing that the person accessing that account is who she or he says they are. What steps should be taken to enroll a new employee on a domain network? You perform checks to confirm the user's identity, issue authentication credentials securely, assign appropriate permissions and privileges to the account, ensure accounting mechanisms to audit the user's account. True false, an account requiring a password, PIN, and smart card is an example of three-factor authentication. This is false. Three-factor authentication also includes a biometric, behavioral, or location-based element. The password and PIN elements are the same factor, something you know. So I guess that's what killed it, was the password and PIN come from, they're part of the same factor, basically. So if you want three factors, then we need to prove either biometric, behavioral, or some sort of location. What methods can be used to implement location-based authentication? So some of the methods that can be used to implement location-based authentication is you can query the location service running on a device or geolocation by IP. You could use location with the network based on switch port, wireless network name, virtual LAN, or IP subnet. Not bad. Number one here. Why might a PIN be a particular weak type of something you know? Authentication. And a long personal identification PIN is difficult for users to remember, but a short PIN is easy to crack. A PIN can only be used safely where the number of sequential authentication attempts can be strictly limited. So if you have a 4-digit PIN, You should only be able, 3 attempts should be enough. If you don't enter it in within 3 attempts, you should be locked out. Now, 4-digit basically implies there's 1,000 different combinations. That's how many 4-digit numbers there are. Actually, I take that back. It's actually 10,000. 000, 0000, and 9999. From 0000 to 9999 makes 10,000. So 4-digit PIN, 10,000 different combinations, and it's not bad. In what scenario would PAP be considered a secure authentication method? And again, it's a legacy protocol that cannot be considered secure because it transmits plain text. ASCII2 passwords and has no cryptographic protection. The only way to ensure the security of PAP is to ensure that the endpoints establish a secure tunnel. True or false, in order to create a service ticket, Kerberos passes the user's password to the target application server for authentication. And this is false. Only the KTC verifies the user credential. The ticket granting service sends the user's account details. A user maintains a list of commonly used passwords in a file located deep within the computer directory structure. Is this secure password management? No. This is security by obscurity. The file could probably be easily discovered using search tools. Which property of plaintext password is most effective at defeating a brute force? And it is the length of the password, the complexity of the password. That would help. I think that's pretty common knowledge. Let's look at the questions for 7C. True or false? When implementing smart card logon, the user's private key is stored on the smart card, and this is true. The smart card implements a crypto processor for secure generation and storage of key. Here's the scenario. You are providing consultancy to a firm to help them implement smart card authentication to premises, networks, and cloud services. What are the main advantages of using an HSM over server-based key and certificate management services? A hardware security module is optimized for this role, and so present a smaller attack surface. It is designed to be tamper evident to mitigate against insider threat risks. It is also likely to have a better implementation of a random number generator, improving the security properties of key material. Which network access control framework supports smart cards? Local login providers such as Kerberos support smart cards, but this is not a network access control, as the device has already been allowed on the network. Alright, let's look at 4. There's the rest of the answer there. What is a radius client? A device or a server that accepts users' connections, often referred to as a network access server or as an authenticator. Using radius architecture, the client does not need to be able to perform authentication itself. It performs pass-through to an AAA server. What is EAPOL? A network access server that supports 802.1x. Port-based access control can enable a port but allow only the transfer of extensible authentication protocol over LAN traffic. This allows the supplicant and authentication server to perform the authentication process with the network access server acting as a pass-through. It's interesting how that works. How does OTP protect against password guessing or sniffing attacks? Again, a one-time password mechanism generates a token that is valid only for a short period before it changes again. All right. And finally, the biometrics section questions. Apart from cost, what would you consider to be a major consideration for evaluating a biometric recognition technology? I think you have to look at the error rates, right? The throughput, and whether users will accept the technology or reject it as too intrusive or threatening to their privacy. How is fingerprint reader typically implemented as hardware? As a capacitive cell? Which type of eye recognition is easier to perform, retinal or iris? And here they say that the iris scans are simpler. What two ways can biometric technologies be used other than for login authentication? And these can be used for identification based on biometric features and in continuous authentication mechanisms. And that is going to do it for this week's lecture video. Stay tuned.